If you are watching this session, then congratulations on reaching this far. So from this session onwards, we'll focus on learning those concepts which will be helpful in doing machine learning programming, artificial intelligence, and data analysis, and dealing with the millions of data. So Python NumPy is actually a library which actually helps to deal with the millions of records in a more efficient manner. In a traditional programming, you might be writing the for loop, which will go through the iteration from 1 to 100 or 1 to 1000. But with the help of the NumPy programming, those for loop can be written in a different way, which will dramatically increase the performance of the system. Because in the traditional way, what the compiler will understand, the for loop is asking to iterate from 1 to 1000 record. This is okay, this is a small range. But what happens if your for loop is iterating to millions of records? So imagine how the computing and compiler performance will be. It will be very slow. So that is where NumPy comes into the picture. NumPy is a library which is written for the basic computing and data analysis, and it stands for the numerical Python. Basically, NumPy is used for vectorized programming. We will come to know when we see some examples here. Okay, so let us first import the library. So here NumPy is my library. I'm importing it as NP, or you can choose any other variable here. So the most common way is NP. So control enter for execution, control enter. So once imported, I'm declaring a array, which is the most common element of NumPy. So an array is having the list of numbers 1, 2, 3, 4. So array 1 is this one, and array 2 is having two lists. So let us see the output now. If you see the first output, I have a list of 1, 2, 3, 4, and then second array gives the two list. Now this array can be represented in a one-dimensional or two-dimensional like a matrix. So let us see. So first I will create a 1D array here. So for creating a 1D array, you have to put np.array and then circle bracket, square bracket, followed by the list of the numbers here. So my output is 2, 4, 5, and my class is NumPy array. Now the difference between the list and the array, if you see visually, you cannot see much difference between list and array. The only difference here is there is no comma here. So I'm creating a 2D array. To create the 2D array, you have to write 2, 3, 4 in a square bracket, separated by a comma, and then 5, 8, 7 in a square bracket. So basically, this is a list a list inside the list. So there are two lists inside the list. So now if you put this one into the np.array, is going to give you two-dimensional array. So 2, 3, 4, and 5, 8, 7. So if you want to multiply the two lists, list 1 and list 2, what you're going to do is to iterate through each of the element in list 1 and list 2 and give the output. This can be done by using the lambda function, which we have studied before. So here I'm using a map function with lambda here, and then I'm multiplying x into y. So basically each element of list 1 and each element of list 2 will be multiplied together, and then output will be the product of these two. Now similar way we can make the use of array, which will be more efficient and more faster. So what I'm going to do here is, so here I have array np.array 1, 3, 4, and then there is the second array np.array. If you see my result, array 3 equal to array 1 into array 2, square of basically the square of array 2. So my output is array 3. So here what we are doing, we are not making a use of any loop. So we are simply multiplying array 1 into array 2. So this is called a vectorized computation. So if you see my output is 0, 3, 36, because array 2 we are first doing a square. So 3 become 9, and then 9 into 4 is 36. So 1 becomes square of 1 is 1, 1 into 3 is 3. square of 0 is 0 and 0 into 1 is 0. So another way of writing this code, let me copy paste this code here in this cell to have a better understanding. So here in the previous example, we have made the multiplication by using the traditional lambda function and the map function. Now with the help of the NumPy Panda, we are going to assign the list as the array 1 and list 2 as the array 2. And array 3 will be the product of array 1 and array 2. So simply we are multiplying array 1 into array 2, and this is called as the vectorize function, vectorize way of computation. So here we are not making the use of any loop. So let me remove this one and then execute. So here we have the output. So my output is also a NumPy array. Likewise, you can also do some other computation. Suppose you want to get the square of the numbers from the list. So we may have to use of traditional for loop. This is an example of a traditional for loop. Now the most simpler way is to square the entire array. So this is again one example of a vectorized computation. So let us see the output. My output is almost same. The only difference is the first is having the list where the numbers are separated by comma, and the second is the array where there is no comma. Previously we have seen how to initialize the array. So here I have initialized list and tuple by providing the actual elements in the list or tuple. Now there are some inbuilt function which is given by Python for the array initialization. Some of them are np.ones, going to give you a list of array of 1, np.0, list of zeros, np.random, create array of random number, np.arrange, create array with increments of fixed size, np.linespace, create array of fixed length. So let us go through one by one. One important tip is that if you want to know more about any function, you can use the inbuilt function help here. Like help np.1. If I want to know what does it do, here is help np.1. Of course, in Google search engine, you can also get a lot of answer, especially from the Stack Overflow website. So here I'm creating an array of 5 rows and 3 columns. So with 1. So what is going to give you, all the elements are 1, but it is having a decimal. So by default, it is having a decimal data type. If I want to create array of row 4 and 3 column, we just put 4 and comma 3 here. So this is an array of 0. So here we have used 0 as a function. Now if you want to an element should be an integer data type, you have to explicitly mention here np.int. int mean integer. So we will have a 1 of integer value. So there is no one decimal here. Similarly, check for the zeros. So there is no. So it is an one-dimensional array where the element is actually a integer. Likewise, you can also create a random number arrays. So element here inside can be of any number. If you print again, if you see here, the numbers has been changed because it is picking up the random numbers. It can be anything. So suppose if you want to print the list of the series, then you can make the use of np.arrange and mention the numbers here. So my first number is the list of number here, and 100 is the maximum number, and 5 is the increment. So I have to print the list of numbers which is like between 10 and 100, but with the increment of 5. So if you see, my first number is 10, 15, 20, and the last number is 95. So in the np.arrange, we knew the size of the step is 5 here, but there are some certain scenario where we actually don't know the size of the step. So in that case, we have to make the use of NP line space. So what's going to do, this 100 is the length of the number. I mean, there will be 100 number printed, whose value should lie between 5 and 6. Because we already know the how much number we need. So it prints the 100 numbers from 5 to 6. Note that this is not an array. I mean, this is a one-dimensional array. Likewise, let's take another example. So it has printed 25 numbers, which are decimal and between 15 to 18. Apart from the above functions, there are some more functions like np.full, np.title, np.i, np.random, and then let us see one by one. So np.full is going to print 4 by 3 array of number 7. So here my element is 7 and it is having 4 rows and 3 columns. Likewise, you can also explicitly mention the array. So this is the one-dimensional array and I want to print 3 times. So in that case, we can make the use of np.title. So here I am printing 0, 1, 2, 0, 1, 2 and 0, 1, 2 3 times it has been printed. Now this array can further be printed in another array. So I'm going to have this 0, 1, 2 array into 3 columns and 2 rows. So if you see here, I am having, if you see here into 3 rows and 2 columns. So I'm having 3 rows here and 2 columns. So one element is this one, 0, 1, 2. Second element is 0, 1, 2. Third is 0, 1, 2. And likewise this one. So np.i prints the value where the default is 1 like this. So it's going to print 3 by 3 array. Usually in our data science project, you will be dealing with the millions of rows and millions of columns. So in that case, your array size will be very, very high. Let's say suppose you are dealing with any one of the random array like rand underscore array and whose number of rows is 1000 and number of columns is 300. So now suppose you want to analyze that what is the dimension of this array, what are the data type in this array. So for that we have some inbuilt function like shape. Shape is going to tell you the columns, the number of rows and columns. Data type is going to tell you that whether it is an integer or float, and it's going to tell you how much is the access number of dimensions is a 1D array or 2D array or 3D array, and then item size is the memory used by each array elements in a byte. So with this you will get a basic idea that how big is the array size, and accordingly you can plan your coding so that the compiler can compile it in a more efficient manner. So let me initialize an array with a row of 1000 and column 300, and then I'm going to print it. So once I print, it's going to print all the 1000 rows, but depending on the visual space here, it will skip some of the rows like ... and then you will get some basic idea of this one. Now this inbuilt function will help me to know a basic structure, a basic construct of this array. So my shape is 1300. Data type is float 64. So by default, the elements in the array are float 64, which is a number. Dimension is a 2D and item size 8 bytes. Now, how do you access the elements from the array? So it is almost similar to accessing the elements from the list that we have discussed earlier. Is based on the index. So my first element is represented by index 0. Second is 1, 2, 3, etc. Likewise, our columns and rows are also indexed in a similar manner. So let me define one random array here. element array of 10 digits, 10 numbers. So I want to access the third element. So what I'm going to do, I'm going to use this array 1D 2, so it will access the third element. Now I want to access two third, sixth, and seventh element. So we can exclusively you can mention the index here 256. But note that the formatting here, it should always be included in a square bracket like a list. Now you want to access the element from the index to third elements onward, so it will be 2 colon here, and you want to extract the first 3 elements, so it will be colon 3. You want to slice from the element third to the element 7, yeah, you can mention here, and similarly subset is here. So printing it, so this is the real as expected 256. Iteration is also similar to the list. So for I in array 1D, so what we are doing, I have this variable I, it will iterate over all the elements in array 1D, and it will give you the output as a square of the elements. Now how do you access the elements on a multi-dimensional array? So let me create our 2D array here. So I'm assigning the list, which is actually 3 lists here inside one big list. So it will convert to a 2D array with 3 rows and 4 columns. Now you want to access the third row and second column. But third row is this one and second column is this one. So how you are going to do this? So in the square bracket, you have to mention the first number is actually an index of a row, and the second number is actually the index of a column. So what it will do, so 2 mean it will go here 0, 1, 2. So this is my third row and first, then 0, 1. So 12. So it's going to print 12 here. Likewise, if you want to extract the second row, then you can simply put 1 comma colon. So it's going to extract the second row. See here 4, 6, 8, 10, which is the second row here 4, 6, 8, 10. You can play here. You can also mention 2 here. So it's going to access 10, 12, 15, 19, which is actually a third row. So now if you want to slice the array on the column wise, so you can mention here colon comma 2. So it's going to print the third columns 7, 8, 15. If you see here, my third column is 0, 1, 2, which is this portion 7, 8, 15 here. So it's going to print 7, 8, 15 like this. Slicing all rows and the first 3 columns. So what's going to do here? So we can mention colon comma colon 3. So this is going to print the first 3 column but all the rows. See here. So it has printed this portion. Now the iteration over 2D array is also similar to the iteration over 1D array. So here we are iterating over the rows. So for row in array 2D, this one. So here we have a program to compare the timing. So if I execute this code here, so what here I'm doing is that the time taken by the for loop using the lambda function is 0.131 seconds, and the time taken by the array multiply is 0.04. So if you see here that the vectorization computation is 26 times faster than the normal for loop. So let's try to understand the code here. So I'm having a 2 list, I for I in range. So my sequence of the iteration will be about 100,000, and then I'm going to do the square on the list 2, which is also 10,000. So this is quite a high number, 100,000 actually. So import time, so I'm importing a library time here. So I have assigned T0, one of the variable of a time. So product list, so I'm going to use a lambda function where I will multiply each element of list 1 with each element of list 2, and then I will compute time T1. So basically T0 is my start time and T1 is my end time, and list underscore time is the time interval. So when the Python compiler execute the code, it will store T0 as the start time, and when this product list computation is finished, it will store T1 as the end time, and list time will store the difference between the end time and the start time. On the other hand, if you have an array, if you have this list in the array, and then when you compute the multiplication, which is a vectorization computation, then our actual output of the time is as follow. So it proves that the vectorization method of computation is 26 times faster than the normal traditional for loop. In this session, we will do some basic mathematical operation on the NumPy array. Let us start with the reshape function in the NumPy. So suppose I have a 1D array. So what does the reshape will do? Let's see. So I have created here a 1D array with the help of arrange function 0 to 12. So there are 12 elements here, and this is a 1D array. Now I want to convert this 1D array into an array of 3 by 4. So what I can do here, I can use np.arrange 0 to 12. So there are 12 elements, and I want to convert these 12 elements 1D array into 3 rows and 4 columns. So I can make the use of reshape function, reshape 3 by 4. So it's give me 3 by 4. Now if you want to do 4 by 3, you can do 4 by 3, but you have to make sure that the product of 4 and 3 should be equal to 12 elements. So we get this one. Let's see, we do 4 by 4. Now if you see the product of 4 by 4 is 16, so it will throw the error. So it will not allow. So Python compiler will understand that we are having a 12 elements, but the reshape function is trying to create a 16 element array. Now we can also do a transpose function. Transpose mean converting rows to column and column to rows. So we can use make the use of t function. Let us see this example. np.arrange 0 to 4. There are 4 elements. I want to make an array of 2 by 2. So I have this array 0, 1, 2, 3. But when I use the transpose function, so it gives me this one 0, 2. So basically this row, this column is now a row in the second array after the user transpose function, and 1, 3 column, this is converted to 1, 3 as a row. Let's see some other example. Let us now define an array sum.array reshape 2 by 6. So basically my sum array is already initialized here, having 12 elements. Now I convert it to 2 by 6 here. Now look at this one. Now sum array reshape 4 minus 1. If my second indexing is minus 1, the array will understand automatically that what should be the column here, minus 1. So since sum underscore array is already having got 12 elements and our row is 4, so by default it will take 3. So the total element become 12. Let's see if I use 3 here, so it will give me an array of 3 rows and 4 columns. So like this. So minus 1. So it will take automatically whatever dimension is needed here. So transposing error we have already covered. Okay. Now there are some ways where we can combine two arrays. Either it can be on a vertical manner or it can be on a horizontal manner. So if it is a vertical, it means that the number of columns in both the arrays should be same. And if you want to be in horizontal, the number of rows should be same. So let us see the example here. So I am having two array 1 and array 2. Let's see, I define here. Okay, so I'm defining two array. Array 1 is an array of 12 elements having 3 rows and 4 columns. And array 2 is an array of 20 elements having 5 rows and 4 columns. Now when I combine together with the help of print/n, so np dot vstack array 1 comma array 2, so vertical stack. So it combines on the vertical manner. But if you want to do in a horizontal manner, let us do a horizontal. So X stack is a horizontal. If you try to combine it, it gives an error because for a horizontal stack to work, the number of rows should be similar. So let us make the number of rows similar here. Let me make it 3 and make it 5 here. So it should be 15. So I define here. So now I can make the use of hstack function. So this is horizontal arrays. Let us move on some other operation which we can perform. Basically, we can perform the operation on the array in a similar manner as we did on the list. But then here we are going to use the vectorized computation method. So let us see. Let's see, I have an array np.array 20 element. This is a one-dimensional array. So on this array, I can apply some of the inbuilt function like this is a mathematics, high school mathematics, sine, cos, exponential, logarithm. So np.sin a, np.cos a, np.exponential, np.log a. Now at this point, you are going to ask me where are we going to apply this high school mathematics? Well, we are going to use this one in our machine learning programming. So that is why it is important to know how the basic mathematical operation can be applied on the arrays. Let us see some other example. So now I am having array A having 20 elements here. So A, now there are two ways. Now suppose I want to have one function to calculate x over x plus 1 for each element of this array. So we can make the use of for loop. This is called as non-NumPy way. Okay. Now our Python has given us a vectorized method where we can apply a lambda function across over the array itself. So we have this np.vectorize lambda x over x plus 1. So it's going to scan through the entire element of the array. Now this one np.linespace 1 to 100. If you remember, this is going to print the sequence of number between 1 to 100 but 10 numbers. Print b. So this is printed 1 dot 12 dot 23 dot 34 dot. By default it is a float. Now fb. So we are already having a function f here that we have defined here. Now on this function we are going to apply the elements in the b, which is a array. So all this element will be applied. So we are going to pass each 1 dot 12 dot inside this function. So that is why my output is an array of 10 elements. Let us start the another session, which is a pandas library. Well, panda library are the most important tool for any data science expert to have. Most of the visualization tool that you might be aware of, like Tableau, ClickSense or ClickView, the backbone of them is actually pandas library. Pandas are used for the statistic calculation. It is used for data cleaning and data transformation, like replacing a null value with a median value or a average value. It is used for the visualization, like creating a bar chart, box plot, etc. These actually did this data gathering, statistic, and data cleaning and transformation, visualization are actually 80 to 90% of the work which a data science scientist do or a data engineer does. That is why the pandas are most important library to learn. I believe you should be doing and focusing more on the pandas concept. Two important concept in the pandas library. One is the series. So panda series is almost similar to the series that we have studied before, like on the list, on tuple, and on the arrays, NumPy arrays. Second important concept is the data frame. A data frame is almost like a Excel sheet. It is a column row structure. And whenever we import any file from outside, like CSV file or Excel file, it will be imported in the form of column row structure called as data frame. And typically, this creating the data frame is the first task that any data engineer does in any data science project. Any data that will be uploaded into the system will be stored as a data frame. So in this session, we are going to understand how to create the series and how to create the data frame, how to import the file from outside like CSV file, how to read, then playing with the data on the CSV file and sorting data frame, doing some calculation, etc. So let's start. So let us now create the series through the Panda library. In the past, you have studied the NumPy array series. So the difference between the NumPy array and the Panda array and the Panda series is the NumPy was having only the numeric as the series. But in the Panda, you can have the string as a series. You can have the number as the series. Second important difference is that the output of the Panda series is denoted, is followed by the index. So let us see. I'm creating the first series here. Variable is s, and then I'm having a series of number 2, 4, 5, 6, 9. This is a defined series. Okay, now you see the output here. Focus on the two things. First, the display is in the vertical format. Second thing, there is a number can be called as an index or an address of each element of the series. So usually they start with 0, 1, 2, 3, 4 and 2, 4, 5, 6, 9 is the actual series that we have created. And the type is the Panda core series. Likewise, you can create a series with the character elements. So this is a one set of program where I'm creating a character series A, B and AF, and then I'm creating a series of the number. So let us see the difference between the two. Okay. Now if you see my first output, again it is denoted by the index 0, 1, 2 and my actual elements A, B and F, and the data type is an object here. Now the second output of this program is here 1, 2, 3, 4, 5, 6 and it is represented by the index starting from 0 to 5 and my data type is integer 64. You can also create a series of the time and date. So for this you have a pd.daterange is a function which is in the pd library. PD is actually Panda library and start date is 11th of September and end date is 12th of November. So what it does, it prints all the date between the two. See my output here. It's 9th of November 2017, 10th of November 2017, 11th of November. Actually, the date here is 9th of November 2017 and 12th of December 2017. It's a format of first is a month, second is day, and then year. Now, how do you access the series? To access it is almost similar to the NumPy arrays. I want to access the third element of series S. If you remember what is our series S here, our series S we have created just now. Okay, this is my series S. So let me print this series S here to have a better understanding. Okay, now I want to access the third element. So let me comment the other code here. Okay, my actual series is print as the output is here, and the output for print S3 is here. So 3 here is third index. So let's see the element corresponding to third index 0, 1, 2, 3. So 6. So 6 is my element. Likewise, if you want to print the numbers from index 2 onwards. So from index 2 is this one 2, 3, 4, 2, 3, 4, 5, 6, 9 here is the output. If you want to print the index from 0 to 4, so my output is 0, 1, 2, 3. So this is the result. In our previous output of all the Panda series that we have seen, the index 0, 1, 2, 3, 4 is automatically created. But also the Python has another option of explicitly define the index. How to do it? Like I have a series 0, 1, 2 and I want my index to be ABC. So you can explicitly define here. See here ABC 0, 1, 2, or if you want A1 or B1 or C1, you can change it here. So it becomes A1, B1, C1. There is another shortcut way. You can you make the use of range function to define a large series. So 0 to 9, and then we have this output as output for this series. Okay. Now the Panda data frame. How to get the data frame? Well, more often than not, you won't be needed to create a data frame. Actually, when you upload the file from outside or when you access the data into the Python console from outside, you have to create a data frame. Like you will be usually be uploading a CSV file or a text file or an Excel file into the system. So when you upload, it will create a data frame. So let us see how the data frame is created first. So here we have this data frame as one of the function in the Panda library. So here I am creating a key value pair. So name is my column, age and occupation. So I am having a 3 column, and under each column I am having 4 elements. So see the output here. Now the output is having 3 columns, name, age and occupation, and rows are denoted by index 0, 1, 2, 3. Let us now play with the real world data, and we will be making the use of Pandas data frame for that. So in this exercise, I have downloaded some CSV file from this website, which is a global market sales data. It is almost like a real world data. So you can visit the website and you can download the following files here. I will also upload the file in this session, so you can download directly there. So these files are having thousands of data and multiple columns. So for example, I have downloaded one of the file, market_fact file. So I am having multiple rows, which is around 8,400 and 10 columns. So in this exercise, we are going to find out how to select the data, how to select multiple rows and multiple columns with the help of the Pandas data frame. So first of all, I'm going to upload this file into our lab, and so we are going to upload the file here. So first of all, I'm going to upload the libraries, import pandas as PD and import numpy as NP. This is a common convention that is being used across the world. So execute this one. So now I'm going to upload my market fact underscore CSV file with the help of the read underscore CSV function and by using the PD library, which is alias for the pandas. So it has been uploaded. So let us see what is the type of this one of this variable market underscore here. So if you see, the type here is data frame. So basically we have uploaded a CSV file in the data frame. Now if we want to inquire, okay, let us first see the data. How does it look like? Control enter. So the console has fetched this many data, but you cannot see the entire data. So basically there are 8399 rows and 10 columns. But if you want to have simply a glance on the data, so you can make the use of head function. So head function is going to return you the top 5 rows. And if you see, each row is addressed by a index. So first row is 0 and last row, which is a fifth row, is addressed by 5 minus 1, fourth index. And the columns are addressed by their actual column name. If you want to see the last rows, so you have to use tail function. The functions here, the function in Python are quite intuitive and it's easy to understand. If you want to understand the data type of each column, you can make the use of info function here. And with data type, it also gives you the number of values in each columns. So if it is a character, it will give you object data type. If it is a number with decimal, it will give you float 64. If it is a number, it's going to give you int 64. So with the help of describe function, you can get some statistic like count, mean, standard deviation. This is the minimum values. This is a 25th percentile value, 50th percentile, 75th percentile, and this is the max value. So the actual meaning of this we are going to learn during our machine learning session. If you want to know the columns name, you can make the use of column function. So these are my columns. If you want to get the shape, like how many rows and how many columns, you can get the use of shape function here. If you want to extract the values, you can extract the values. So values will be extracted in a NumPy array. Now if you want to do a sorting, so you can actually base on the actual column name. So here I am doing sorting by profit, and by default the sorting will be ascending order. If you want to have a descending order, you have to simply put the ascending here as equal to false. If you see, in all our output I am using a head function so that I can query only few data. But if you want to query the entire one, you just remove this one. So it's going to query all the data. If you want to do a sorting by two columns, profit and sales, and you want descending order, you can make the use of this one. Now in the following session, let us see how to do a slice and dice the data from the data frame. So if you want to select the rows from indices 1 to 6, so what you can do, you can mention the market fact here 1 to 7. So what is going to do here is that the 1 is actually the index and 7, the last one is always minus 1. You have to remember this point here. It's a bit confusing, but if you practice the programming, there will be no more confusion. Now, if you want to select alternate rows starting from index 2, let me make the use of this one. So start from the index 2 here, 2, and then it jumps by 2. So 2, 4, 6, 8. If you want to start with 3, and if you want to make it jump by suppose 4, it's going to give like 3, 7, 11, 15, 19. Now, how we can do the selection based on the column name? So let us see here. I have this market fact data, and then I want to select the data based on the column name. I want to select all the rows under one column, which is profit. So it gives me sales on data under profit, and it output is only 5 rows. The other way is we can just put the column name here, dot sales. This is the most common, other common way. So it gives you the same output here. If you want to select a multiple column, just specify the column name in the list, cost ID, sales, and profit. So here my output is cost ID, sales, and profit, and it gives me the 5 row because I'm using a head function. Let us see the type. So the output of this is also a data frame. So multi-column is my data frame. But if you want to select the second row only, how do you want to select? So what happens here is that if you try to select the second row, so what happens is that pandas will give you the error because panda doesn't know whether this number 2 is actually the label 2 here, or is it the second index, which is 1, which is the second row. So in this case, it doesn't know. So in the following lecture, in the next session, we are going to see how we can select one row with the help of the label or with the help of the indexing. In the previous session, we have gone through uploading the CSV file into the data frame, how to know the summary structure of the data frame, and how to do a selection or slicing and dicing the data from the data frame. Now in this session, we are going to learn two important methods to select the values from the data frame. The first is the position based index and second is the label based index. So let us first start with the position based indexing. So I have the market fact underscore df data in which the data is already uploaded. So here, to have a better understanding, I'm going to park 10 rows into another data frame which is market fact underscore df1. So we can do by this way. So the 10 rows are already parked under market fact df1. So this is also actually a data frame. So now in the position based indexing, we are going to make the use of the function ilog given by pandas. So if you want to select the third row and fifth column, so what happened here is that since this is the index based method, so second is the index. So this is my second index and fourth column. So my fourth column is 0, 1, 2, 3, and 4. So remember that the column indexing also starts with 0. 0, 1, 2, 3, 4. So under sales column, you have to look for the row corresponding to the second index, which is 4701.69. Selecting a single row and all column. So simply you have to specify the index of the row here. So basically it's going to return 0, 1, 2. So third row. The output is vertical here, column and values. You can also make the use of 2, colon. It's going to return the second row sorry, it's going to read the third row and all the values under the column. For selecting the multiple row, simply you need to specify the index of the rows here. But then it should be also be like a list. So third, 7 and 8 here. Note now, if you want to select multiple rows, the other way is to make the use of 4 colon 8. Note that 8 is not included. So basically 8 means the 8th record. So we start from the index 4 and 8th record. Now how to do a single column selection? You have to simply specify column, comma 2. So it's going to select the third column, which is the shift. So let's see the third column, which here 0, 1, 2. So this is the third column. If you want to select all rows in multiple column, so column, comma 3 column 8. So it's going to select third column to 8th column. So cust ID. So let's see cust ID position here. So cust ID is 0, 1, 2, 3. So this is the third column. Now, if you want to do a selection of multiple columns and multiple rows, how you can do this? 3 colon 6 is going to select from the row 3 to 6, and 2 colon 5 is going to select from row to column 2 to 5. Important point to note here. Now 6 here is actually the 6th row, not the 5th level index, not the 5th level record. This you have to note it down. Okay. Now the other way and more intuitive way is to make the use of the label based indexing. So that is df underscore loc. So this is the label based indexing. So let me select my market fact underscore df on data. So now here we are going to select the second row and column sales. So this is the second label here, 2 and sale, which is this. So it's going to return 4701. Fifth label row, market fact underscore df1 loc fifth, which is this one. If you want to select the multiple rows, simply mention 5, 6, 7. Actually, in your real life project, you can make the use of any one of the method, which is more intuitive for you. So now market fact df1 loc 2 colon 5 is going to select 2 to 5th row. So this is also same as the previous one. This is also same as the previous one. Now there might be a certain scenarios where you want to select the particular rows with some filter condition. The way to do is to index the rows with one of the column values. So here I'm going to replace this indexing 2, 3, 4, 5 with the column values under order ID. So if you see my output here, the order underscore ID has taken the role of indexing. Now how can I select here? So now if I want to select the rows corresponding to the index or ORD underscore 5446, let's see my output here. So ORD 5446 is what? 1, 2, 3. So basically there are 3 and 4th row. There are 4 rows here. So we're going to select 4 rows. 5446. No, there are only 3 rows. If you want to select based on the index 5446 and you want only two columns, ship ID, customer ID, just mention here. Now if you want the multiple rows, so you can mention the index of the rows as a list here, and you can mention sales colon profit. This is useful when in an Excel file you are having a large number of columns and where listing all the column name is not possible. So you can simply put the start column and end column. So it selects from sales to profit. All the columns here also, whichever lies between sales and profit will be displayed here. Now, if you make the use of the Boolean function, so it's going to return all the rows. So if it is true, it's going to return the first record. True is second. The third record is false. So false, it is not going to return. Like 5446 is a false, so it's not returning the 5446 here. In this session, we uploaded the market fact data file where you have gone through the column like product ID, ship ID, sales, and then shipping cost, etc. And we also learn how to access these values and row access with the help of position-based indexing and label-based indexing. In this session, we are going to upload the multiple files like market fact data, customer dimension, product dimension, shipping dimension, and order dimension. Before we start this exercise, you can download this CSV file into your local and you can have a glance just to have a basic understanding of the data. So now, after uploading this file into the Python console, we are going to merge all these files together and then we are going to do some calculation like sum, average, or maximum, minimum, basic aggregator function. And we are also going to learn how to do the summation like Excel like summation like with the help of the pivot function. So let us begin. So first of all, we are going to upload this to library, import NumPy as NP, Pandas as PD, and then we are going to upload all this file into a data frame. So let us query top 5 rows or the first 5 rows just to have a basic understanding. This is the market fact data. If you see under the market fact data, we have this column order ID, product ID, ship ID, customer IDs. Now this order ID is linked to the order dimension file. Product ID is linked to product dimension file. Similarly, ship ID and cust ID is linked to your shipping dimension file and customer dimension file. So we are going to merge all these files together with the help of the order ID, product ID, ship ID, cust ID, which are linked to market fact data. So now customer dimension. So my cust dimension is this one, customer name. Now this cust ID is linked to this cust ID of market fact data. Product dimension. Now we have this product ID, which is a unique identifier. Now this product ID is linked to the market fact data product ID. Let us see the data in shipping dimension. So in shipping dimension, ship ID is linked to the market fact data ID. Similarly, order dimension, here order ID is linked to market fact data order ID column. So this is my order ID here. So now we are going to merge all this table into the main table, which is the market fact data. And for this, we are going to use the function pd.merge. So merge is the inbuilt function with which we are going to merge the multiple tables. Now, how do you merge? We have to use the inner statement on customer ID. So basically, we have to mention the column, which is a unique identifier, which is a cust ID. So after merging, I have named my data frame market underscore cust. So it is very important to name your data frame which is easy to understand. So market underscore cust, so market fact data and customer dimension data. Now, after the merging, we can see how to do a query. Now here what I am doing here, after merging market underscore cust data, I am doing a filter condition where I am selecting all those records with the order ID equal to 5446. So this is similar to a filter condition. Now merging the product, so market cost, product dimension. So what here I have done, I have named my data frame now market cost product to demonstrate that we are having 3 files here. Now this is a way to put a filter condition with the multiple filter condition. So here what I have done, I have taken a product category is equal to office supply and customer segment is equal to corporate. So this is going to return all the rows from the market customer prod data with this condition. Now let us see some of the arithmetic operation that can be performed on the data frame like addition, subtraction, multiplication, division, etc. So let us take an example of a FIFA team of 2018. So this is my dictionary and I am going to convert into a data frame. So like I have a FIFA team which is Belgium, France, Croatia, Japan, Sweden, Brazil. Then another column is matches played and goals scored. So here if you remember, I'm going to index my data frame with the column FIFA team. So let us see the output here. So this is my output matches played. FIFA team is my index. So similarly, let us make a FIFA team of 2014 with the same columns. So this is my second data frame, which is FIFA 2014. Now we can simply add up FIFA 2014 and 2018. So it will give me the output. It will add up the numbers and it will give me the output. If you see here, matches played and goals scored are actually the sum of the FIFA team 2014 and 18. So Python is very smart and it can recognize that which is number and which is character. But if you see in the Korea is having NaN. NaN here means blank value or null value. Because Korea team is in FIFA 2014, but it is not in 2018. There is no Korea. So when you add up the number with a null value, it gives you the null value. But then Python has a way to fill up the null value with some value. So like total FIFA. So what I'm going to do here, so I'm going to add a FIFA 2018, add FIFA 2000 and fill value 0. So it's going to replace the null value with 0. So now you see the Korea is having 3. Also, you can do percentage calculation on column wise. So let us see. So what here I have done here, you can see a new column is added on the data frame. You can simply put the goal percentage and put some calculation. So this is my output. You can also do the sorting. So here in the previous session, we have learned how to do merging of the multiple data frame and do some arithmetic operation like sum, division, etc. and how to apply some filter condition in order to select the rows which satisfy the certain criteria. In this session, we are going to merge all the data frame and do some group aggregation function like summarizing or calculating the sum over the certain condition. So here I am re-uploading all the data into the data frame. So now here I am merging all the data frame. If you see here how I am merging, first I am merging market fact and customer dimension with a join condition cost ID. And then I will merge this market cost with product dimension. The resulting will be market cost underscore PR product. Then likewise, I'll merge all the data frames. So finally, I'll be having this data frame, which is the merging data frame of all the files. Now suppose if somebody asks you what is the highest sale by each product, for which product category we have the highest sale. So what I'm going to do, I'm going to use a group by function where first I will group by the data frame by product category. So we're going to use group by function. And if you see the output is actually a data frame, group by data frame. Now we can simply apply the sum on the column which is being urged. So my group product category was calculated by this condition, by this program. Now you can use the column name and calculate the sum. If you see the output, it gives for each product category the sum. The other way is to simply put the sum here. You can put the column name here and the function here. And if you want to do, let me comment this one. Okay, my output is still same. Now, if you want to do order by, you can simply put dot short value ascending false. So it will give me a descending order. Now, if you want to give the output in a data frame way, so you can use this one, pd.data frame enclosed in a bracket. So this gives the output in a data frame manner. So I can use same thing here, pd dot data frame enclosed in a bracket. You have to make sure the spelling is correct here. So my output is like this in a data frame way. Now you can also do grouping based on the two column. Suppose my question is which product category and subcategory has the highest sale. So you can do group by product category and product subcategory. So this will be in a group by as a list enclosed in a square bracket. So the rest process is same. Now we do a summation on the sale column. So this is my output. This is my product category and this is my product subcategory. If you want to see the output more properly, you can use data frame function. Okay, my output is more user friendly. If you remember the describe function, so with the help of describe function, you can get an overall statistic of a particular data frame. So here my group by was already a product category and product subcategory, and all the statistical values are here. So count, mean, standard deviation, minimum, 25th, 50th, 75th percentile, and max value. So this is a very useful function to have an overall picture of the data. Now, if somebody asks you to calculate the sale percentage by each product category and subcategory, so you can use this function. So now this is my percentage. So what I'm doing, we already have an output from this one. I'm simply dividing the sum by the sum of each product category and subcategory over the overall sum. Okay, now let us move on to the next topic. So we are going to learn in this upcoming session that how to modify the existing values on a data frame and how to add a new column. So let us take one example. Suppose I want to add a column which is sales underscore 500, where the value will be true if the sale is more than 500 and the value will be false if the sale is less than 500. So what I'm going to do, I can do this thing by two ways. First thing, by using a function. So here I'm defining a function which is sales underscore 500 in the function. So now the Python has a very special function which is inbuilt, is called apply function. So with the help of the apply function, you can simply call the function here sales 500 and it will pass the value from the sales column. So what will happen? So what we are doing here, this is my data frame, market cost PR ship underscore ORD. If you remember, this is a merge data frame of all the file, and I am adding a new column sales underscore 500, the value of which will be defined by the function this one, def sales underscore 500. Now in this function, with the help of the apply, we'll pass the value into this function sales 500 and we'll get a new value. So here is the output now. If you see here, my last column sales underscore 500 is added here. Now false, it is false if your sales is less than 500. So let us see my sales here. Okay, my sale is 136, so it is false. If you see the next row, My sale is 4,701, so it should be true. So this is true. The other way to do same thing and more easier way is to make the use of the lambda function. So here in the lambda function, we are not writing any exclusive function. Apply function still we are using. So instead of calling the function sales underscore 500, we are directly defining the lambda function here. So lambda x, if it will return true if x is greater than 500, else it will return false. So my output is same. So here we have sales 500. Now you can also modify the existing data. So I have a sales data which is an existing value. So I'm going to round up these values like 136.81. I want to round up. I want to remove the decimal here. So I'm going to use the round function. So let us see the output here. So now 136.81 after rounding, it has become 137 and 0.69 is 4702. So here also we have used the lambda function and the apply. So with the help of the apply and lambda function, we are rounding the value. Okay. Now if you have worked with the Excel, you might be aware of the pivot functionality in the Excel. So same functionality Python has built. So what we are doing here, we have a value sale, index is product category, and aggregate function is mean. So what we are doing here, we want to calculate the mean sale value by each product category. So see my output here. If you want to have another function, you can just replace the mean with the max function. So if you return the max value, so give me the max value. If you want to do over the rows column structure, we can do like this, rows pivoting. So I think you might be aware if you are working on Excel. So this is my output. So here my index is product category, which is actually under the rows, and product subcategory will come under the columns. Data cleaning is one of the most important tasks in any data science project. Typically, a data scientist spends around 60% of time in cleaning and organizing the data. So why data cleaning is so important? It is because if the data is not clean, then you may have a wrong output, a wrong business decision, which may lead to a downward trend. Since there are lots of structured and unstructured data, so data cleaning has become a very time-consuming and tedious task. So one should be properly equipped with all the arsenals to clean the data. And the most common way of cleaning the data are replacing the numerical value with mean or median value, or replacing it with some of the most frequent occurring value in a column. For a categorical value, the missing value can be removed or replaced with the most frequent occurring values. And depending on the business decision, you may also choose to delete some of the rows. So more the data is clean, the more accurate business decision can be made, and less complex will be the machine learning algorithm. Hello friends, in this session we are going to learn some data cleansing technique. Most of the time, the real world data is not perfect, and more often than not, they need to undergo some data cleansing tech steps. Like there are some columns which have blank values, and there are some columns whose values are out of range. For example, in the case of student data, there might be a student whose age is 0, or there might be the students whose height is more than 10 feet, which is in practically is not possible. So that is why the data cleansing steps is very, very important before doing any data analysis. If the data does not undergo through the data cleansing technique, in the later stages, the business decision which is made based on the data might be wrong, and it may create havoc to the company. In our example, we are going to take up the real estate data from Melbourne, Australia. So let us try to understand the data in the Excel first before we proceed to upload this. So here my first column is suburb, second is address, then we have the number of rooms in the unit, then price. If you see under the price column, there are some rows having no price, blank values. So that is where we need to do some data cleansing. Then we have the date. Then there are some unit which doesn't have any bedroom, bathroom, or car parking space, land size, building area, everything is blank. So this is the garbage data. Then even latitude, longitude is blank. So now let us upload this data into our Python console and let us do the data cleansing activity. So first of all, I'm going to import our two important library, NumPy as NP and Pandas as PD. And then I will upload my real estate data into a state variable and execute. So there's the output. So I'm having 5 rows and 21 column. Basically, the real estate data is having 21 columns. So let us explore further on the real estate data. So now I'm having around 23,547 rows. So here you can see the type of the variable, suburb, address, or string character. The rooms is a number. Then type of the room is object. Object mean character, and price is 464. So now the first step in the data cleansing is to find the how many columns are having NaN or null values. So for this we are going to use the isNull function. So here we have a lot of values which are false, it means it's not null, and there are some values which are true, it means it is a null. But this is not a good way to analyze the null values. Let's find some other option. So now here I'm going to count the number of null values. So here we go. Now from this output, you can see here that the price is having 5151 rows which are having no price at all. Then we have bedroom 2, bathroom having 4481 records with null value. Then bathroom is having 4484 records with null value. So this is quite a large amount of records which are having null values. So now there are several ways to treat the null values. So now depending on the business problem, following are the some of the ways to treat the missing values. First, if the column is a continuous variable, suppose if it is a number or a float type, then you can replace the missing value with a mean or a median. But again, it again depends on the business problem that you are having. The second way, if the value in the column is out of bound, replace the value with the highest available value within 99 percentile. Let me give you an example here. Suppose in a room there are 4 employees and somebody asks you to find the median value, the median salary of these 4 employees. And out of 4, one of the employee is Bill Gates. So imagine how much salary he'll be having. Let's say he's having $10 million salary. But the other employee on an average might be having $5 to $10,000 only. So somebody asks you what is the average salary of this 4 employee? Of course, the average salary of this 4 employee will be under around $10 million. But what is the median salary of the employee? The median salary of the employee will be around $10,000. So that is where you have to treat the outlier. So in our case, the outlier is Bill Gates' salary. So we have to replace the Bill Gates' salary with the maximum salary of the 3 employees. And if the column is a character, then you can replace the value with the most frequent occurring value, or you can choose to ignore. And if there are some columns which are having most of the data with null values, let's say suppose 50% are missing, then the rule of thumb is to drop the column. Otherwise, it may give you the wrong business decision. And there are some advanced technique to treat the missing value, which is like using regression method like linear regression method, etc. Where this can be used for those business problem where those columns are too critical for a business decision. So let us find if any column is having null. So we are having some columns which are having null values, and there are few columns which are having all the values not null, like suburb, address, rooms, and type are false. It means it doesn't have any null value. So these columns are good for the further analysis. But if you see like price, then postcode, bedroom, bathroom are having null values, so these need treatment. Now let us see one by one each column. So now this function x is equal to 0 will give the null value on the axis on by column wise. If you want to see the null values, some of the column having null value is 14. Now if you want row wise, so here it shows the null value by each row. So there are 23,000 rows, so it gives for each rows the false or true. Now if you want to find the total sum, so I am having around 17,351 rows with the null values. Now this function state is null all. So this is going to give those records which are having all the value with null. So in our case it's 0. But if there are some data where all the rows are having null value, then the best thing is to drop. Or even if more than 50% records are having null value, again you can decide to drop it. So now treating the missing value. So let us see the steps which are for treating the missing values. So first of all, let us find the percentage of the values by each column, how much values are having null. So in our case, if you see, my price is having 21% which is missing. Then building area is having 57%. Here build is 50%, council area 33%. These are quite high percentage values which are null. So now, so we can simply, because building area, year build and council area, more than 30% are having null value. So it is best to drop this column as it will not give any added value to our business decision. So we are going to drop this one by using drop function. It has been dropped. So let us again compute the percentage. So now my price is 21%, bedroom, bathroom 19%, car 19%. So let us now analyze the row wise and find out if any values are missing with more than 5. So here I have few rows where the number of columns missing is more than 5. In our case, we have 18 columns in a state data set, and then we want to find out around 30% of data, which 30% of data per row which is missing. So that is why we have taken 5. So it's around 4,278 rows which are having more than 5 columns with missing values. So I have 4278. Let us see how much percentage are missing. So we can use length, which will give you the total number of rows. So I have 18% which is missing. So what I'm going to do, I'm going to retain the rows with less than 5 lengths. NaN. So now let us note that the price column have 21. So here we have price column is having 21% which are missing. Value, let us remove some of the row with rows price having NaN. As price is important to our study, we will remove the rows. So to remove the rows, we can use NumPy library function is nan state price. So here we are removing. So we have already removed. So let us now again see the percentage of missing value. Now here my price is 0%.